In this video, we shall look at the position vector, and this video serves as an introductory video to vector calculus. What is a position vector? A position vector is a fixed vector which locates a point in space relative to another point. So if this is x, y, z plane, this is in 3 dimensions, this is the Cartesian coordinates. So we can find a position vector which is directed in this direction. So R is the position vector. So we say consider a point whose location in space is specified with Cartesian coordinates x, y, z. So this point is located at this center point, which captures the x, y, and z coordinates, which is a Cartesian coordinates. So we are not looking at the spherical or cylindrical coordinates. Our interest is in the Cartesian coordinates specified by this parameter. Now consider the directed distance. Okay, this directed distance, which is a vector quantity. So this is this extends from the origin to this point. So this is what is called the position vector. This is the position vector. This is the position vector. So this position vector can be expressed in 2 dimensions as well, as we shall see in the later part of the video. So if an object moves from this point to this point, you now see that this is the directed distance. So if this is the initial position, let's say this is R1, and this is the final position, this is R2, this distance will now be, R2 minus R1, and is showing the displacement. So this is the displacement, final position minus the initial position, and it is in this direction. So this is north, this is east, so is in the direction of northeast. So this is northeastern direction. So if we should know the final position and initial position, we can find this distance. Now that's why it is called directed distance. Of course, this is a displacement. So a directed distance is what? A displacement. So this position vector can be represented with this. This is the position vector. It can be represented as, of course, we consider the directions. We say x, I plus y, j. These are the unit vectors in the direction, plus zk. So this is in what? In 3 dimensions. So if it were to be in 2 dimensions, we have something like this, where this is the y axis, this is the x axis. If this is to be the position vector, so we now see that this will be given as, this is xi plus yj. So we consider this and consider this. So this is in 2 dimensions, and this is in what? 3 dimensions. So previously we considered this 2D representation of position vector. This is y-axis and this is x-axis. Assuming a point runs from here to here, where this P in 2 dimensions is given as x, y, since we are working in 2D plane. So we can find this position vector. Of course, this position vector at this point will be given as, so the vector itself is given as this is x I plus what? Yj. So this is this vector. So this is the notation of this vector. As we have only 2 points here running from here to here, so this can as well serve as a displacement vector if we find the change in the position vector. If we should find the change in the position vector. So change in this position vector is the displacement vector. The displacement vector. So in this case now, at this point, we have the coordinates of x and y to be 0, 0, and we don't know this. So let's say we don't know these coordinates. So the change in the position vector, which is the displacement vector, will be the final position. If this is the final position and this is the initial position, so we'll say final position minus initial position. So in this case now, let's be consistent. Let's use R2 minus R1. And of course, at this point now, we have xi plus yj minus this point, it will be 0. So that the change in position vector here will now be xi plus what? Yj. So if we have a point represented here, let's say this point is represented as 3, 4, we can find the displacement vector. Of course, I say that this is the displacement vector, that is change in position vector for this case. So in that case now, we use change in position vector as this is final position minus initial position. For instance, you are given this and you're asked to find displacement vector. So we now have 3i, because the x component is 3. Then you have plus, remember this is our R2 and this is our R1. So this now will be 4yj minus the R1 here. So we still maintain that R equals xi plus yj. In this case, this will be 0i plus 0j. So this is 0. So this is 0i plus 0j. So the displacement vector here now be 3i plus 4j minus 0. So this will be 0 finally. So that what we have now will be 3i plus 4j. So this is the displacement vector or change in the position vector. So what happens if it is represented as this? What happens if it is represented as this? So still in 2D, this is y and this is x, and this time around you have the initial position as this, labeled as RA, and you have another one as this, labeled as RB. So of course both originated from this point. So the coordinates here will be okay, let's not consider this first, since we have two positions here. So from vector addition, we can find this position vector. This is the position vector. We say that a position vector is that fixed vector. Of course, this is, we can give this direction, is that fixed vector which locates a point in space relative to another point. So this is a point in space, so relative to this point. So we can do this. So you add vectors by joining the head of one to the tail of the other. So you have something like this, such that this becomes the position. This becomes the position. So see what we do now. See what we do. So this position here will be, so this is R plus, so this is RA, this is RA, so we have added this and it equals RB. So it means that from this expression we can comfortably write that R is RB minus RA. So in this case now, this is what we have as the displacement. This is what we have as the displacement vector. This is the displacement vector. And of course, this again gives expression for the change in the position. Okay, so this is the position of the, if a particle moves from this point to this point and moves again from this point to this point, so we can find the change in the positions. So as this gave us the position, is as well giving information for the change in position between these 2 points. So remember how we did this. We only had one movement from this point to what? This point. So in this case now, since we are working in 2 dimensions, we can say that for the first one, that is RA, so following from this formula, so we can have that this is, of course we can decide to use this to show direction. Okay, we can use this to show direction. We can have something like this. Okay, but we can still use not put this. All right, now from this formula we can have that this is XA, this is SAI plus YAJ. Similarly, RB will be XBI plus YBJ, such that the displacement vector now, displacement vector given by the change in the position will now be, this will now be as we said, RB minus RA, which is what we have here. So that we now have, this is RB is XBI plus, this is YBJ minus, this will be XAI plus YAJ. So if we know XB, know YB, know XA and YA, we can find the what? Displacement vector. Now let us look at the idea of displacement vector, which is change in position vector in 3 dimensions. So if these are particles located differently in different dimensions, so this is Z, in this case this is Y, and this is X. Okay, so we can find that if a particle is to move from, let's say initially from this point to a point A, let's use another marker, to a point A, and at this point, since it is in 3 dimensions, we can say that this A is having these coordinates X. Okay, in this case now it will be XA, YA and ZA, since we have X, Y, Z positions. So let this be point A. So if, of course, the position here, the position vector here will be given as what? RA. All right. So we say that a position vector is that fixed vector which locates a point in space. This is a point in space, 3D space, relative to another point. So the point here now, okay, is A. This is point A. Now let us locate another position vector. Let's say another one is in this direction, and in this time around let it be B, so that is having these coordinates. Of course, this is Cartesian coordinates in X, Y, Z plane. Okay, so we are not looking at spherical or cylindrical coordinates as I said initially. So this will be XB, and the Y component will be YB, and the Z component will be what? ZB. Now, of course, the position vector here will be RB. We say that position vector is that fixed vector which locates a point in space. This is a point relative to another point. So how do we find the displacement? Displacement is change in position vector. So if this is change in position vector, of course this will be the final RB minus RA. And look at how this is gotten. So if we draw, if this vector is given in this direction and this is given in this direction, we can find another vector. Okay, change in position vector gives us the displacement vector, which is the final position minus the initial position. So you join a vector head to tail. So this could be the tail of this vector, and this is the position now, which corresponds again to the change in position, which corresponds to the change in position. So of course what we have here now is we added R to this is RA, and it gave us RB. So if we make R subject of the formula, you have that RB minus RA, which is the final position minus the initial position, which is what we have here. So of course we now know that for a 3D space now, that this RA will be, and write this as, if you look at this position now, this is the position we want to write, and it's given in terms of X, Y, and Z. Remember, we are looking at 3D plane. So this is not along maybe the horizontal direction. We are not looking at one-dimensional representation. So what we would have written would have been, this is X, A, I, showing that this is along the X direction, plus this is Y, A, J, showing that is along the Y, plus this is Z, A, K, showing that this is along the what? Z direction. These are the unit vectors in that direction. Similarly, for this position RB will be XBI, okay, plus YBJ plus ZBK. So to find the displacement vector, which is the change in this position vector, it will be, that is this, it will now be RB minus RA, which we have shown here. So let us solve an example problem. So let us solve this problem. The problem says consider a particle that moves in these directions, okay, that moves from point A, this is the point A, to point B. Find the position vector at point A and B. Using this position vector, calculate the displacement vector. So following from what we did previously, these are the positions. We have final position and we have the initial what? Position. This is final and this is initial position. Now let us bring the points. So look at the points. We have 4, 5, 6. So this is X position, this is Y position, and this is Z position. So we can represent this following from this position vector representation in 3 dimensions is given as XI plus YJ plus ZK. So in this case now, our position, our first position, which is the initial position, so since this is denoted with A, this will be SAI plus this will be YAJ, and this will be ZAK. And we can now fix in what we have here. You now notice that XA will be 4, YA will be 5, and ZA will be 6. So that we have that XA will be, this is 4I plus YA is 5J plus ZA is 6K. So similarly, we can do that for RB. So RB, so we have this. So RB, let us bring out the position. This is RB, the point 7, minus 4, 9. Of course, this will be X, Y, Z. So that RB will be XBI, right? Plus YBJ plus ZBK. And of course, you know that this is XB. So that RB will be 7I, okay? YB is this, okay, because of this minus here, plus this is 9, which is 9K. This is 9K. So that we can now find these are the position. The question says find the position vector at point A and B. So the position vector at point B is this, and the position vector at point A is this. And to find the displacement vector, which is the change in position vector, as we saw earlier on, this is the displacement vector. Displacement vector, which is change in position vector, will be RB, which is the final position minus initial position. And what we now have is that this will be, so this will be 7I minus 4J plus 9K. That is RB minus RA is 4I plus 5J plus 6K. So if you do this, if you clear bracket this, so this is 4J plus 9K, we clear bracket, this is minus 4I. So minus going into this is minus 5J, minus into this is minus 6K. So that we now have, we continue from here. So continue from here, this is we bring all the I's together, all the J's together, and all the K's together. So this is 7I. We bring this minus 4I. This is minus 4J. This is minus 5J. This is plus 9K, and this is minus 6K. So 7I minus 4I is 3I. This will minus 9J, and this will be, so 9 minus 6 is 3 plus 3K. So this is the position vector. So this question can as well ask you to find the magnitude of this position vector. So the question is, can ask you to find the magnitude of this position vector. So you can try this and put the answer in the comment section. So let me give you hints. If a vector is given, in this case now position vector is given as, this is X AI plus Y AJ plus Z AK. To find this magnitude of this vector, if this is a vector, of course what we looked at here is change in a position vector, which is given by the displacement vector. So of course this is the answer we got for the displacement vector. So you can find the magnitude of this displacement vector. But assuming a vector is given as this, to find the magnitude, you have this, say this is in 3 dimensions, we have it as SA, that is the square root of this, plus YA square plus ZA square. But if it is in 2 dimensions, like R equals XAI plus yaj. This will be, so the magnitude be square root of xa square plus ya square. So of course, what do you think will be the magnitude of this displacement vector? So from here you have this, so this will be like saying x a I, okay, minus, this will be y a j, this will be plus z a k. So you can find the magnitude following from this formula. So find it and put the answer in the comment section. Do have a wonderful day ahead.